Hey math kids, today we're going to talk about the quadratic formula. We're in chapter 4, section D still. This is the third video for this section. And we're going to start on example 11. Before we start though, let's talk about the quadratic formula. So ax squared plus bx plus c equals 0. And if we have something in that form, then x equals this. So hopefully you remember this from the previous class. And let's just use this for example 11, part A. So we're asked to solve for x. And so the first thing you want to do is write down your A, your B, and your C. Once again, just from this equation. Now we're going to plug it in here. So we have x equals opposite of b. So since it's -2, I'm just going to do +2. And then we get -2 squared minus 4ac, and then that's all over 2a. Alright, from here, I would suggest simplifying that. So 2 times 1 is 2. Then I'm going to multiply all these together. So -6 times 1 is -6. And then -6 times -4 is 24. Okay, that ends up being positive, so I'll keep a plus sign there. -2 squared is +4. And so if I add those, I get 28. So with a little bit of simplification, we end up with something that looks like that. Now, we need to look at this 28. So that's going to be 4 times 7, and then 4 is 2 times 2. So we have a pair of 2's and a single 7. So we can rewrite this as 2 plus 2, because we took out the 2's, square root of 7, all over 2. Now, from here, we can simplify this. So we have 2, everything's divisible by 2 on the outside of the square root, so don't worry about what's on the inside. Since it's all divisible by 2, let's divide it. So this 2 becomes a 1, plus or minus, and then it would be 1 root 7, but we don't need to write the 1, because it's like saying 1x. We don't need to write that. And then on the bottom, we'd also have a 1, but having a 1 on the bottom of a fraction is also redundant, and so this is our answer for x. Now we're going to do the second part of example 11, which is asking the same question. Okay, so I'm just going to write the quadratic formula again. Okay, first step, write your A, B, and C. So A is 2, B is 3, C is -6. Then we plug it in right here. So opposite of B, so we write a -3. It's positive here, but it's negative over here. 3 squared minus 4ac, that's a 6, and then 2a. Okay, so we do the bottom first, so that's a 4. Then we do -6 times 2, that's -12. And then we do -12 times -4, that gives us a 48, and it's positive. 3 squared is 9, and so if we add that, we're going to get 57. Feel free to use a calculator if it makes it easier for you. Now, 57 can't be broken down, and so this is actually our final answer. Just make sure we say x equals. on to example 12. And I need some space for this one. Okay, so this one says use the discriminant to determine the nature of the roots. So let's talk about what the discriminant is. So they use delta for the discriminant. And the discriminant is just the piece of the quadratic formula that is under the square root symbol. So whenever it says discriminant, know that it's talking about this. So on example 12, part A, it gives us this quadratic equation. And we're going to start it the same as we did the other two problems. We're going to say A is 2, B is -2, C is 3. But we're only going to use the discriminant. Okay, so B squared, so we have -2 squared minus 4 times A times C. We simplify that, so that's 4. And then we multiply these out, so that's 6 times 4, which is -24. So we end up with -20. So our discriminant in this case is -20. Now that's not our final answer because it wants us to state the nature of the roots. So what we're going to do, if we have a negative number under a square root, what type of values does that give us? If we have a positive value under a square root, what type of values does that give us? And if we have 0 under a square root, what does that do for us? So since it's negative, we're going to get an imaginary solution here. And if we look at the quadratic formula as a whole, that's actually going to give us 2 complex answers. Okay, because remember, in the quadratic formula, there's actually a plus or minus out in front of all of these. And so it gives us 2 answers. Okay, 2 complex, let's call them roots, I guess. Let's say roots. Okay, if it's positive, then we're going to get 2 distinct real roots. So that just means 2 that are different numbers. And this one, we'll still get 2, but they'll be the same. So 2 repeated real roots. Okay? And that's because plus or minus 0, square root of 0 is just 0, plus or minus 0, positive 0, negative 0. That's the same thing. And so that's why we'll get 2 of the same answer, essentially. We'll get a 3 and a 3, for example. Now, just to kind of show you on a graph what these mean, move this up here. So this first one, so the first case we'll do in white. If we end up graphically, it's just going to be something like this or something like this. We'll get a parabola that does not cross the x-axis. Now if we have this situation, this is probably what you're most used to. You're just going to have a parabola that crosses the x-axis at 2 different spots. It could be right side up or upside down, doesn't matter. And the last situation, it's a parabola that just kind of kisses the x-axis. So it's like that. Okay? And that's why we get 2 of the same answer, because it only touches one place. Okay, now going back to the question, we have almost our answer right here, but our discriminant is negative. And so that's this first case that's underlined in white. And so the answer to this one is just going to be 2 complex roots. So when it asks for the nature of the roots, it's asking for that sentence right there. Okay? All right, let's move on to part B for this one. So once again, it wants us to use the discriminant to determine the nature of the roots. So we just write our discriminant here. So our B is -4. Our A is 3, and our C is -2. If we simplify that, these two become negative 6. And if we do negative 6 times negative 4, we get positive 24. And then if we do negative 4 squared, we get 16. Add those together, we get 40. And so that is our discriminant. If we go back up here, so we had a positive value. And so that tells us we have two distinct real roots. So we just say two distinct real roots. And that's our actual answer that we're looking for. Okay, let's move on to example 13. They give us a new quadratic equation. This time, though, the constant is represented by m. And it says, find the discriminant, and hence, find the value of m, which the equation has repeated roots, two distinct real roots, and no real roots. Okay? So no real roots would be the complex case that we talked about before. So our discriminant, once again, b squared minus 4ac. And we're just going to plug it in. Even though we have this m, we'll just plug it in. So our b is negative 2. Our a is 1, because there's an implied 1 right here. And then we multiply that by c, which in this case is m. So we'll still simplify this. Negative 2 squared is 4. Negative 4 times 1 times m is negative 4m. Alright, so we're going to look at all three cases. So remember, the three cases are negative, positive, 0. So we are going to set it equal to all three of those cases. So first, let's start with the negative case. So we are going to say 4 minus 4m is less than 0, because that would be a negative number. Our goal is to solve for m. So I am just going to add 4m over here. And give us a little bit more room. So 4 is less than 4m. Divide by 4, divide by 4. 1 is less than m, which is kind of backwards from what we want. So we're going to say m is greater than 1. So essentially, we are going to say for the negative case, which this actually is part C. Sorry, I'm doing it a little bit out of order. But we're going to say that m has to be greater than 1 in order to create a negative discriminant, which means we have no real roots. So this is no real roots. And this is part C in your book, just to be clear. Okay, for the positive case, which is two distinct roots, so this is B. So I'm doing this backwards, I guess. So this is two distinct real roots. That case is positive, so we're going to set up something very similar to this, where we say 4 minus 4m is greater than 0, because we want a positive number. Okay, we go through the algebra again, add 4m, 4 is greater than 4m, divide by 4, divide by 4, 1 is greater than m, or m is less than 1. So when m is less than 1, then this stuff happens. We have two distinct real roots, which is a positive discriminant. Alright, final case where we have 0, which is two repeated roots, and that is part A. And we just set it equal to 0 this time. So 4 minus 4m equals 0. Add 4m to both sides. 4 equals 4m. Divide by 4. 1 equals m, or m equals 1. So when m equals 1, we get two repeated roots. Okay? So if you have any additional questions, please come to Math Lab. But for now, calculator.